Okay. So what are the components of operating systems or what are the functions of operating system? Basically, first component that is very, very important, that is process management and CPU scheduling. What is a process? When program is ready for the execution, that programs becomes a process. At that time, we can say that the process management is required. If multiple processes are available on the ready queue, at that time processor or process management is there for managing the all processes. And suppose the what is the CPU scheduling? CPU scheduling is nothing but the what is CPU scheduling? CPU scheduling is nothing but the suppose three processes are ready for the execution. So which one first will start its execution? That depends on the policy which is available with a CPU scheduling. Suppose it is available with first come first serve. Suppose OS is using a policy that is first come first serve scheduling algorithm. Suppose process P1 arrive first, then OS will start the execution of the program P1. If process P2 arrives P2 arrive first, then programmer or OS will start the execution from the process P2. That is nothing but the CPU scheduling. Next component of operating system is memory management. So whatever memory or whatever program which is ready for the execution, the OS will take or loader will take that program from the secondary storage and load into a main memory for the execution. And whatever, suppose the memory is not available on the main memory, it allocate some spaces to the required process and deallocate the spaces to the unrequired process. That is a task of memory management. Next comes the file management. File management is nothing but the creation of new file, deletion of a file. These are the few tasks which is performed with the help of file management. Next is IO management. IO management is nothing but the input output device management. What are the resources which are required during the particular process that make available to the process. And last is nothing but the system security, provide a security to the system. So these are the components which are required, which are the OS components. Now we'll discuss the all components in detail. So first component is a process management. In process is a programming execution. Okay. So suppose uh, process needs a resources for the execution and there are resources that can be managed with the help of operating system. Suppose we have a two process, process P1 and process P2. This is process P1 and this is process P2. Suppose initially process P1 is ready for the execution, so it comes in a critical section. This is nothing but the critical section. This is a critical section. So initially process P1 is on a critical section. When process P1 completes its execution, then it comes out of the critical section and whatever resources which are required for the process P1, suppose R1 and R2 that was occupied by the process P1. After execution of this, the resources R1 and R2 get released. And suppose for the process P2, again these two resources are required. At that time, process P after getting the resources of R1 and R2, process P2 will start its execution. Now, how the concept of this dependent and independent is, I will tell you that. Then we'll see the critical section. Suppose two process, basically process is of two types. One is dependent process. This is reprocess, that is nothing but the dependent process. And second is independent process. If the resources are not common or nothing is common in between these two processes, that is nothing but the independent process and that can execute it independently without any communication. If the process are dependent, means what? Process P1 and process P2, these two are the dependent process. That means what? Few resources which are required for the process P1 Suppose that is also required for the process P2. Suppose the R1 and R2, these two resources are the required for the process P1. And the suppose for process P2, R2 resource and R3 resource. These two required for the execution of the process P1. So we can say that when resource R2 is occupied by the process P1, the process P2 cannot start its execution. So this is what the dependency comes. So whenever resources are common for the two processes, or we can say that when process is dependent, at that time the concept of critical section is available. What is a critical section? If two processes are dependent on each other, at that time when the process P1 is ready for the execution or when process P1 start its execution, at that time the dependent process of the process P1 cannot start its execution. So on the process P1, process P2 is dependent. So when process P1 goes into critical section, process P2 cannot start its execution. Suppose after few time, process P1 get released. At that time, process P2 can enters into critical section and start its execution. So this is what the dependent process. So what these are the management which can be done with the help of process management. Next is what? What are the tasks that can be performed with the help of process management? First is process creation. Second is process deletion. Process suspension is nothing but the process going under waiting state or infinite waiting. That is nothing but the deadlock state. Or whenever process is resumed, or we can say the process got its resources at that time, it can start its execution. That is nothing but the process resumption. So whenever process is dependent at that time, the concept of process synchronization and process communication comes in a picture. So this is nothing but the process management. This is the first uh, component of an operating system. Next is memory management. One more thing that which is available in a process management, that is what? PCB. What is PCB? PCB nothing but the process control block. Every process is having their own PCB. This is nothing but the PCB. It is like a data structure of a process which is managed by the processor. Suppose the process P1. Process P1 is having their own ID, whatever resources are which are required for the execution of this process, that is also stored in the PCB. Whatever execution time, suppose execution time for process P1 is what? 5 seconds. That is also stored here. Okay. Suppose currently process P1 stops its execution and it's on the waiting state. So state of a process is also stored in a process control block. So the all details related with each and every process that can be stored in a process control block. So we can say that for every process there is one PCB. For process P1 there is one PCB. For process P2 there is another PCB. Okay, and that can be managed with the help of memory management. We can say that memory is a large array of words or a bytes, each with its own address. Every process or every array is having their own address. Okay, it is a repository of quickly accessible data shared by the CPU or IO devices. The main memory is volatile and it loses its content in case of the system failure, because the small size of a main memory or RAM is very small and it is a volatile. And OS is responsible for the things such as it keep a track of the which part of memory are currently being used by the phone, and it decide which process to load when memory spaces become available. Allocation of a space in a memory, deallocation of a space in a memory, that can be done with the help of memory management. So these are the tasks which are performed by a memory management. Basically, there are few memory management algorithms are available. For example, So we can say that okay, that we'll discuss at the time of memory management. Okay, next is what? File management. We can say that file is a collection of related information which is defined by its creator, and commonly used files represent a program which is in both source language and object forms. Object form is nothing but the after convert execution of that program that converted into object code, and object code that converts into binary code which is readable by machine only. So operating system is responsible for the activity related with file management. It create a file. After creation of that file, deletion of the file is also required. That can be done in the file management. Directory creation and deletion of a directory, that can be done in the file management. Support of the primitive for the manipulation files and directories. Mapping files onto secondary storage. File backup on a stable, non-volatile storage media. All these tasks that can be done in the file management. Next comes that is a IO system management. It controls the devices connected to the computer. IO devices vary widely in their functions and speed. The device driver, which is required to provide an interface to the IO devices. Okay, so these are the component or functions of the operating system. Next, we'll see the structure or system structure of a operating system. So why it is required to see the system structure of OS? Because OS tends to be complex as it provide a many services. OS provides so many services. Because of that, we can say that the structure of OS is very complex. It supports variety of hardware. It supports a variety of software. The OS architecture help us to manage the complexity. Because of the architecture complexity, it is possible to manage the hardware as well as the software. It organize the OS components. The whatever components which are OS is having, that can be managed in a system structure of a OS, and it specify the privilege with which each component uh, executes. And in modern OS, it is a large and complex architecture is available. Because of that, it is required to be created very carefully. It should not only function properly but should get modified easily. The common approach of the partitioning is the task into smaller components, and each of the component is well defined portion of a system with a well defined input and output function. So we'll see the structure of a OS. First, we'll discuss about the simple structure of OS, then we'll see the monolithic structure, then we'll see the layered approach of OS, then we'll see the microkernel. What is there in a simple structure of your OS? So what is there in the simple structure of a OS? So same here, I'm drawing one diagram for a simple structure. So it, basically simple structure is divided into four layers. Below layer is nothing but the BIOS device driver. This is the lowest layer of the operating system. Okay, BIOS device driver. On the top of the BIOS device driver, DOS device driver. DOS is nothing but the distributed OS, that is distributed operating system device drivers available. This is the layer which is present on the top of the BIOS device driver. BIOS is nothing but the basic input output devices. Okay. On the top of the DOS OS, system programs are available. What are the system programs? The programs which are like compiler, interpreter, loader, linker, utilities. These are the system programs which are the available on the top of the DOS distributed DOS device driver. Okay. So this is how this system program and device driver is connected. On the top of the system program, application programs are available. This is the application program. Application program is directly interact with system program. Again, we can say that application program can directly interact with DOS device driver. And again, it is directly can do interaction with BIOS device driver. This system program can interact with DOS device driver as well as it can interact with BIOS device driver. So we can say that in simple structure, each there is interacted with each other. So simple structure in a simple structure whereas this lacks of model design, making its component tightly integrated. It is a small, fast, and easy to develop. It is a less secure and unstable. Example of simple OS is MS-DOS. We can say that it allow application directly to access the hardware. We can say that is application programmer can directly interact with the hardware. A single program failure crashes the entire system because here each and every layer is connected with each other. So single program failure crashes the entire system. What are the advantages? While talking about advantage, we can say that fast performance due to fewer layer. Here only few layers, that is only 4 layers are available. Because of that, it is a fast performer and it is easy to develop because of the kernel program. So these are the advantage. But while talking about disadvantage, we can say that it doesn't have clear structure and making it complex to manage and lack of security as any layer can access to any layer. So we can say that it is lacks of security as process can directly access the system resources. This is related with simple structure of operating system. Next, we'll talk about the monolithic structure. In monolithic structure, see this is a application program, this one, and this is what uh, kernel. Inside a kernel, memory management, device driver, dispatcher, file system, all things are available. And in between application and kernel, system call interface is there. System call is nothing but the program. It is a call in between the running program and kernel. So here is what are the tasks that can be performed in a kernel is memory management, process management, inter-process communication, file system, input-output management, network management. All this can be tasks performed with the help of kernel only. A monolithic structure OS is a single and large program where all essential services that can run together in a kernel mode only. Example of monolithic structure is Linux or Unix. Here we can say that kernel is a central component of the OS that ensures the communication between hardware and software, and it provides fundamental services like all the management, memory, process, IPC, all that can be managed. Okay, what are the advantage? Regarding advantage, we can say that it is having a fast performance due to direct communication between a component. And uh, what are the disadvantage? While talking about disadvantage, we can say that it is difficult to maintain a smaller error, can crash to the entire system, and there is a security risk due to lack of strict isolation between a component. So these are the two drawbacks of a monolithic structure. Next is what? Layer structure. In layer structure, OS is divided into layer structure is nothing but the simple structure. See here, simple structure and layer structure both are same. Here, all the OS is divided into multiple layers. Lower layer is layer 0, that is this one L0 is a computer hardware. And top of the computer hardware operating system is there, that is layer 1. And on the top of the OS utilities or programs are available, that is L2 layer. And last layer is nothing but the application program. End user can directly interact with the application program. Here, programmer can interact with utilities and OS. and operating system designer can communicate with the computer hardware. Typically, OS layer consists of data structure and set of operation which can be invoked by the higher level. It simplifies the debugging and system verification since layers uses of functions and services of the only lower layer. Example of layer code approach is Linux. So see the layer structure. This is a layer 0, that is hardware layer. On the top of the hardware layer, layer 1, that is a OS is there, then utilities is there, and last layer is layer N, that is user interface. Suppose this is a layer X. Okay, layer X can be affected from layer X plus 1 and from the layer X minus 1. So this is a layer 1. Layer 1 can get affected from this lowest layer. Below layer 1, layer 0 is there. So layer 1 can get affected from the below layer, that is layer 0, and above layer 1 plus 1, that is layer 2. So these are the two interdependent layers. Last approach is microkernel approach. So see here, this is nothing but the application, file system, device driver which are available in a user. This is what user mode. Second is kernel mode. In kernel mode, all the interfaces communication, memory management, CPU scheduling is done. And lowest layer is hardware. Hardware can directly interact with kernel mode. What are the things that can be performed in kernel mode? Interfaces communication, memory management, and CPU scheduling. So we can say that the kernel contains basic requirements such as scheduling. All this can be performed in a microkernel. The other functions of the OS which are removed from the kernel mode and run in the user mode. Other function like file man system and device driver. These are the two tasks that can be performed in a user mode. And these functions can maybe device driver. Okay, these are okay. And microkernel makes sure that the code can be easily managed because the services are divided into user space. This means that it is a less code running in the kernel mode, which results in increased security and stability. Example, Apple Mac OS and 264 Unix. These are the two examples of a microkernel approach. So again, I will repeat this. Only essential OS, example process and memory management run in the kernel space, while other services run in a user space. So you can think microkernel architecture like a company where only critical tasks are handled by the core team while other tasks are outsourced. Okay. So talking about advantages, we can say that it is a more stable. A failure in one model won't crash the whole system and easier to extend and modify. So these are the two advantages of a microkernel. Relatively disadvantage, it is slower due to frequent communication between kernel and user space and more complex in our implementation. So these are the two disadvantages of operating the microkernel operating system. Now see the difference between microkernel and monolithic OS. Monolithic kernel is a large process running in a single address space. Monolithic programs run in a single address space. But microkernel is divided into separate process called a server because few part is available in kernel mode and few part like a IO management and file management that are available in a kernel mode, user mode. So it is a process where it separates into servers. Code. If you are talking about code, in order to write a monolithic kernel, less code is required because maximum part is available on the kernel. But while in a microkernel, more code is required because few things are available in a user space, such as file management and IO management. For management of this file and IO, more code is required. Next, talking about security. If the service crash, the whole system collapse in a monolithic kernel because everything is available in a kernel mode only. If any services crash, that means it collapses the entire system. In a microkernel, it never affects the working of a microkernel because few part is going to execute in user space and few in a kernel space. While communication, single static binary file available is monolithic kernel. In a microkernel, communication is done through a inter-process communication. Example of my monolithic kernels are Linux, Microsoft Windows, Windows 95, Windows 98, Windows ME. So these are the examples of monolithic kernel. And microkernels are macOS, L for Linux. So these are the examples of microkernel. So these are the applications of a OS. Now see the difference between protection and security. What is security? Security which grants the access to the specific user of a system user. But related with protection, protection deals with the system access to certain system resources. Okay. In security, the external security threats are associated with a system. Protection is there for the internal threats associated with the protection of a system, such as few files that cannot be accessible by another user only. So this can be protection which is given inside itself only. In security, convoluted queries are handled by the security system, but simple queries are handled in a protection. Security uses a mechanism like encryption, authentication. It is also known as certification. This is required in the case of security. But while talking about protection, it tries to determine the files that could be accessed or permitted by a user for a special user. That means what they are trying to give a protection for that particular file only. Security implements the process to enforce the data integrity, and protection implements the authorization mechanism. So this is the basic difference between protection and security. In security, there is a concept of encryption authentication is available, but in case of protection, authorization mechanisms available. Okay.